Good morning, everybody, and welcome back to Next Door NetAdmin. A little while ago, I did a video about setting up a PXE server, or a PXE server. And I covered, among other things, TFTP, DHCP, and the actual boot process. And I demonstrated it working in a virtual machine. One little problem with that: as much as it worked in the virtual machine, and I was able to keep it working for virtual machines just fine, for whatever reason, it didn't actually work with hardware when I tried it. I have no idea why it didn't work with hardware when I tried it. There was no reason for it not to work. So something is different between how Hyper-V PXE boot works versus how physical machines, such as Lenovo machines in this case, process their PXE boot settings. So I've been working on that a little bit. Separately, I have another environment where I wanted to do a PXE boot system, but I can't actually replace wholesale the DHCP server. It's running in Microsoft DHCP. That can't be changed, and it can't be easily modified either because it's running in a failover cluster environment. And I don't want to add Windows deployment services and all that other stuff around it. So I had a reason to be digging a little more deeply into the process of how PXE boot can function. And so that leads me to what I'm talking about today, which is proxy DHCP. Do you mean like a DHCP helper where you point a DHCP relay agent or an IP helper, if you're working in Cisco devices, that points to a DHCP server on a remote subnet? No, and yes, but no, specifically for this one. Let's go back a little bit and talk about DHCP, the fact that it has options, and then how PXE kind of found its genesis and how that integrates with DHCP. DHCP is how servers will typically offer an IP address, a subnet mask, router, DNS, domain name, a whole bunch of different things. And in fact, these are all different options within DHCP. I've talked about option 43 in a previous video, one of my first videos actually. But everything in DHCP outside of the actual IP address is an option. The subnet mask is an option. The router address is an option. There's a bunch of them. So that gives us some flexibility to pass along different parameters to your boot clients. PXE came about a little bit later, and PXE standing for Pre-Boot Execution Environment. The thought was you can use DHCP to pass some of these options onto a client that is looking for a network boot. You can pass along what's your server IP, what's the file name that you're supposed to be retrieving, all these other options that go with that. Cool. How does this actually work in practice? Do you have to go modify your DHCP server and tell it how to respond with this additional information? Do you want to give this additional information out to every single device, even those which can't network boot? There is an option, option 60, which when the client sets it as PXE client, it lets the server know that this is a device that's looking for PXE boot. And so you can give it additional options such as the next server IP address and the file name that it's supposed to be booting from. Cool. Not all of these options come predefined. In fact, in Microsoft DHCP server, at least one of them does not. You'd have to create a custom option and then provide that blindly. Who knows? There's also the facility in many PXE servers these days to offer several different file names, depending on whether the client that's booting is a 32-bit system, a 64-bit system, maybe a certain vendor hardware class requires something with special options. Who knows? So how do you have that kind of flexibility? You can detect the PXE client sends it, what its architecture is and everything else. But the sort of if-then proposition of, if this is a 64-bit client, give it this 64-bit boot. If it's a 32-bit client, give it this 32-bit boot, is not something that is available in Microsoft DHCP server, certainly. Some other servers have that capability, that flexibility built in. Not Microsoft DHCP server. That's just the way it is. It's basic DHCP. That's what it is. All right. So if we can't modify our DHCP server, or if the modifications are insufficient to support the functionality that we want, then what do? This is where proxy DHCP comes into play. The PXE standard also specifies proxy DHCP, which is a second server that you can sort of slide into place on the network. It doesn't replace your existing DHCP server, but it works in tandem with it. A device boots up, it says, "Hi, I am looking for DHCP, and I'm putting into my request option 60, PXE client." Okay. Your DHCP server, the main one, doesn't necessarily need to know anything about it. It can send, here's an IP address and the basic parameters to make that work. Cool. The proxy DHCP server does not offer an IP address. It just sort of slides in there and sends a second packet and says, oh, and by the way, here's some additional DHCP options for you, including your network boot file name, your network boot server, and just the stuff to make PXE work. Your PXE client can receive the IP address from the main DHCP server and then listen to these other additional DHCP options so that it has all the information from the two of those put together in order to go and start a network boot sequence. Cool. I was like, this is slightly more complicated, a little more complex, and yet it's really not. Because the idea there is, if you have a DHCP service that can't be modified or shouldn't be modified or is under a different administrator's control, let's say you've got a big corporation. DHCP is managed centrally through corporate IT. Cool. If you want to implement network boot separately for a separate project, how do you make that work? Do you have to set up your own isolated network? And that doesn't necessarily make a lot of sense. And if you're setting up your own isolated network, then you're introducing a router in between the two, possibly some NAT, firewalls, etc. That makes a network admin's skin itch, okay? But you can possibly put in a proxy DHCP server which doesn't tamper with any of the IP addressing for the network. It just adds a couple of options to support network boot. And that can be under the PXE admin's control rather than DHCP admin's control. So is it a little more complicated? Yes, but administratively, the aim is to simplify things so that you don't have to go and modify everything in the DHCP server all the time. Okay. How does the proxy DHCP server know when it needs to send these additional options? It's a decent question, but consider how DHCP works. If you've got the DHCP server on the same network segment, the client broadcasts a DHCP request. Because it doesn't have an IP address, it has to do a broadcast. Because it's a broadcast, everybody on the network segment can hear it, including the proxy DHCP server. So if it sees a broadcast from a DHCP client that says it's PXE compatible, it can just send its offer without an IP address, but with the additional options necessary to make PXE boot work. Okay, that's understandable. What happens if the client is on a different subnet, a different network segment altogether, and it's not sending a broadcast? Well, what happens in that case? What happens is when the client broadcasts, it's picked up by a DHCP relay agent, or, again, in Cisco terms, an IP helper. It's converted from a broadcast to a unicast and sent directly to the configured server IP for the DHCP server. Cool. But in this case, the proxy DHCP server isn't going to receive any sort of a broadcast. How does it know? Well, it won't if you leave it that way. If, on the other hand, you add another IP helper, Cisco's can support up to 8 IP helper addresses per interface. That's from memory, so feel free to double check that. But it supports up to 8 of these per interface. And there's always the possibility that you can have multiple relay agents. Let's say if you have DHCP failover. They're not clustered on the same IP address. There's 2 different IP addresses. Fine. You might have multiple relay agents. So what you do is you configure your main DHCP server as one of your IP helpers or relay agents. And for the second one, you can configure your proxy DHCP server. So that when a client sends out a broadcast, your router will catch it, forward it on to both places, DHCP server and proxy DHCP, as unicast. And then both servers can respond to that. DHCP will respond with IP address, proxy DHCP will respond with PXE information. Proxy DHCP does not necessarily know that an actual IP address has been handed out. And it doesn't have to know that an IP address has been handed out. All it needs to know is the subnet from where the request is originating, same as the actual DHCP server needs to know. If you have a DHCP server that has multiple subnets, if it's receiving a broadcast or a packet without a gateway address, then it's assuming that it's for the local subnet, the subnet that is connected to the interface on which it's receiving the inbound request. Proxy DHCP will work the same way. If it's receiving a packet with no gateway address, it's assuming that it's for the subnet connected to the interface where the inbound request was received. But you can configure it with multiple subnets. And if it's gone through a DHCP relay or an IP helper, then the gateway address in the packet will be set so that the DHCP server knows it's for this other subnet, a remote subnet, and it will allocate from that subnet. Proxy DHCP works the same way. It's not allocating addresses, but it needs to know for what subnets it should respond. If it's only configured for the local subnet and it hears a request coming in from a remote subnet where the gateway address is set, if that's not configured, it'll say, this isn't for a subnet that I'm supposed to service, and it will not transmit boot information. So even though it's not handing out IPs, your proxy DHCP server still needs to know what subnets it needs to respond to. There's a lot of information in that, I realize. And I have got that working. I'm not going to demonstrate all of it to you today. I will actually demonstrate it to you a little bit later. But this kind of a setup allows us to do a lot of the things that we couldn't do with a straight DHCP server. It allows us to have the flexibility to say, if you're receiving a 64-bit client that's booted using UEFI, that gets one type of boot client. If you're getting a 64-bit client that is BIOS boot, maybe it's different. 32-bit UEFI, 32-bit BIOS, maybe a separate boot program for particular hardware manufacturers or hardware IDs, whatever. You can have this sort of flexibility in play. And that can be cool. You can also use this to add PXE functionality where you have a DHCP server that can't be modified. Maybe it's coming off of some ISP's equipment and you can't tinker with it. Maybe it's something like Microsoft DHCP server, where it's impractical to modify it, short of installing Windows deployment services, and that's its own whole thing. So there's some interesting ways of doing this, and if you think about it, you can figure out how it's supposed to work and plan it out accordingly. And that's a cool thing that you can do with network administration. Hopefully you found that interesting and it was useful for you. I am planning, like I said, to show you a working example of how I've got this set up. I just didn't have a lab environment ready in time for this video. And I figured I would give you more information about proxy DHCP and how it works. So 2 reasons for me to talk about it first and then demonstrate it for you later. But for now, like I said, hopefully you found that interesting and useful. If you have any comments or suggestions on how to do things or suggestions on things to talk about in future, feel free to let me know down in the comments section. For now, though, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.